Welcome to Homework Lib.
Hello students, so we are given with CHF2Br and we have to, in the first part, we have to tell us total valence electrons. So basically we have 1 carbon, 1 hydrogen, 2 fluorine and 1 bromine atom, and their valence electrons are 4 for carbon, 1 for hydrogen, 2 into 7 for fluorine, so 14, and 1 for bromine, so 7 for it, so for 21 and 5, it's basically comes out to be 26 valence electrons of CHF2Br. And in the part B, we have to tell what is its structure. So its structure can be drawn as fluorine, and 1 hydrogen there and 1 bromine there. That is its tetrahedral structure. Then in the part C, we have to tell the formal charge. Formal charge can be calculated by valence electron minus non-bonding electrons minus half of bonding electrons. So for carbon, we can write 4 minus 4 minus half of 8 into 4 minus 4 into half of non-bonding electrons are 0 for carbon, so it comes out to be 0. For hydrogen, 1 minus 0 non-bonding electrons and minus half of 2, it also 0. For fluorine 2, it came out to be 7 minus 6 minus half of 2, 0. And for bromine, it is also 2, 7 minus 6 minus half of 2 is also equal to 0. So basically all atoms have 0 formal charge. Then we know that in the D part, we have to tell number of atoms in this question. So basically we have 5 atoms, 1 carbon, 2 fluorine, 1 hydrogen and 1 bromine, so 5 atoms, and lone pair of electrons on central atom we have to tell. So basically carbon has 4 valence electrons and it forms 4 bonds, so it has 0 electrons as lone pairs. Then we have in the F part we have to tell the molecular geometry, that is tetrahedral, and in the part G the electronic geometry is also tetrahedral. Then in the H part we have to draw its dipole moment structure and tell whether it is polar or not. So we can draw it in this way, in fluorine and hydrogen. Then let us show this color. So bromine is more electronegative than carbon, fluorine is more electronegative than carbon is more electronegative than this, and fluorine is more electronegative than this. So basically it has a net dipole moment and thus it is polar in nature. So our final answer comes out to be, so in this way we can answer these questions. I hope you find this solution useful.